Next, we're going to talk about the union of sets. The union of sets A and B written. A union B is the set of all elements that are members of set A or of set B or of both sets. The union symbol is kind of just like a tall U without a tail, okay? So A union B is equal to the set of all x such that x is an element of A or x is an element of B. Now, the intersection of sets is written A, and then the intersection symbol is kind of like the union symbol but upside down, is the set of elements common to both sets A and sets B. So A union B is the set of all x such that x is an element of A and x is an element of B. So it has to be in both. So for our first example, we're going to be taking a union. Now a union is an OR example. Okay, so we have the set of 1, 3, 5, 7, or 10, or the set 6, 7, 10, or 11. So I'm trying to find out what elements are in the first set or the second set. So when I'm doing a union, I can simply just take every single element that occurs in the first set and then just add any extra elements from the second set that I haven't yet written. So 6, that's not in there yet, so I'm going to write it. 7 already is, so I don't have to bother writing that. 10 already is written in the set, and then 11 isn't, so I'm going to add that. So this is the union of the two sets, and as long as it's in one or the other, then you're good. Next is the same two sets, but this time we're trying to take the intersection. The intersection is the AND, meaning it has to be both in the first set and it has to be in the second set. So what do you see common in both the first set and the second set? Well, I see 7 in common, and I see 10 in common. Those are the only two elements that are common in both sets. So 7 and 10 are the intersection of those two sets. Next, let's take the set of all A, B, C, union that with the set of D, E, F, and G. So union, again, that's an OR. So it has to be in one or the other. So I'm just going to start listing everything in one set and then add everything that I haven't yet seen in the second set, which is just basically everything. So we have the set of A, B, C, D, E, F, G. Now, the next one is an intersection, which is an AND. So it has to be in both the first set and the second set. What elements do you see that are in the first set that are also in the second set? Well, there aren't any. So what we have is the empty set. So you can either look at it as a set notation with two braces without anything in it, or you can write it with 0 with a slash through it. That also means the same thing. Let's do some more examples using letters for the set notation. So we have U, the universal set being 1, 2, 3, 4, 5, 6, 7, A being the set of 1, 3, 5, 7, B being the set of 1, 2, 3, and C being the set of 2, 3, 4, 5, and 6. So when I'm doing A intersect B, that's an AND. It has to be both A and B. So what do you see that's common in both A and B? I see a 1 common, I see a 3 common, and so A intersect B is 1, 3. I'm going to go ahead and erase those highlights because I'm going to do it again with B and C this time, but this is B union C, so that's an OR. So it has to be in one or the other. So I'm just going to go ahead and start with all of the elements of B, 1, 2, and 3, and then add any elements in C that I haven't already written. 2 is already written, 3 is already written, so check, check. 4, 5, and 6. I'm going to add those as well. So that is the answer to B union C. Next I have A intersect the empty set. So that's an AND. So we need all of the elements that are in A and all the elements that are in the empty set. So because the empty set has no elements in it, which elements are common between the empty set and A? Nothing. So the answer is the empty set again, or you can write it as 0 with a slash through it. Next we have A OR, which is a union, the empty set. So we need to list everything in the set A, and then we list everything in the set B that's not already written, which is nothing, and that is going to be our union. Okay, so if we look at the last two results here, note for any set P, if we have P intersect the empty set, notice that that was very similar to A intersect the empty set. It turns out we're always going to get the empty set, or you could put the 0 with the slash through it. But if I take P union the empty set, I always get itself the set P, because there's nothing else to add from the empty set, so P union the empty set is always going to be P. Next, we're going to use several of the operations of complement, union, and intersect to find new sets in the same problem. So here's an example where I have the universal set being A, B, C, D, and E, the set of A being B and C, and then set of B being B, C, and E. So I'm trying to find A union B complement. So I have to take this in 2 steps. First thing I'm going to do is just do A union B inside the parentheses. So A union B is going to be the set of anything in A or anything in B. So in A we have B and C, and in B we have B, C, and E. So I'm just going to add the E. So that's my A union B. So now I'm going to do A union B complement. So the complement is what is not in A union B. So what are the values that are not in A union B? Well, A is not in A union B. B and C are. D is not, so that would be part of the complement, but E is. So A union B complement is the set of A and D. For our next example, we have A complement intersect B complement. So I'm going to need to do A complement by itself, then I'm going to do B complement by itself, and then take the intersection of both of those. So when I'm going to erase some of these things up here, A prime, or A complement, I need to find all of the elements that are not in A, but they are in the universal set. So A is in the universal set, but not in set A. B and C are, and then D and E. Alright, for B complement, B, C, and E are in B, so who is not in B? Well, A and D. Now I need to find A complement intersect B complement. Intersect, that's an AND problem. And so it needs to be in both A prime and B prime. So A is an element that is in both, and D is an element that is in both. So the set of A and D is the answer to A prime intersect B prime. Alright, let's do this one more time. This time we're going to have 3 sets. Again, you have to take this step by step and just do work from the parentheses inside to out. So on our first problem, we have A union B intersect C. Because B intersect C is inside the parentheses, we're going to do that part first. So we have B intersect C would be, what are the values that are in both B and C? Well, B is in both, and F is in both. So this part is B and F. Now I still have to union that with A. So I'm going to take A and union that with the set of B and F. So what do we have for A? A is A, B, C, and D. And then we're going to add any of the elements in B, F that are not yet written. Well, B is already written, but F is not. So there's going to be my answer, A, B, C, D, and F. All right, next I'm going to do A union B. So I have all of the elements of A or all of the elements of B. So I have A, B, C, and D. For B I have A and B, but they're already written, and D, that's already written, so I'm not going to bother adding that. And then I'm just going to add the F to the set. Intersect with, so I'm going to do that later, A union C. So A union is OR, so I can list all of the elements in A, and then keep listing all of the elements in C that aren't already written. B and C are already written, so that's great. The only thing I need to add is F. So now we're going to take all of the elements of the red set and intersect them with all of the elements of the green set. So all of the elements that are in common, we have A that's in common, B that's in common, C, D, and F. So all of those elements are in common. For our last example, we need to first do C prime because that's on the inside of the parentheses, and I need to work out the complement first. So I'm going to come over here and just work out the complement of C prime. So all of the values that are not in C but are in the universal set U. So A is not in C, B, C, D is not in C, E is not in C, but F is. Okay, so now I have C prime. I'm going to work B union C prime. So the B would be A, B, D, and F. And then I'm going to, because this is a union or, I'm just going to keep adding all of the elements of C prime that I haven't already written. A I've already written, D I've already written, but E I haven't, so I'm going to go ahead and add E. So I have A intersect the red set A, B, D, F, and E. So intersect means and. It has to be both in the A and the red set. What's common in A and the red set? Well, A is common, B is common, D is common, and it looks like that's it. That's all that's common. And so that is my answer for part C. And this concludes our lesson on sets.